So let's look at some other types of equation questions that you get on ACT. Okay, we're resuming now. Can I please have silence? Okay. Let's look at some other types of questions now. Another type is when you have to compare coefficients of different equations. For instance, they say there's this expression and this expression. They are equivalent, right? They're equivalent. They're identical to each other. If they're identical to each other, what's the value of C? Now, how do you think about this? This is factorized form. This is simplified form. So you can simplify that first form as well and see what that gives you. So try to simplify this and see what that gives you. X squared plus 10x plus bx plus 10 times b. Okay? And you are given that this is supposed to be the same as x squared plus 3bx plus c. What's the coefficient of x squared that we're getting? 1 in both of them. 1 equals 1. That's not quite helpful. But what's the coefficient of x and what's the constant term now? Can you figure that out? What's the coefficient of x in this expression? What's the coefficient of x? Sorry? Coefficient of x here. 10? 10 and? 10 and b. So how do you write that? We can take x common and that leaves us with 10 plus b inside. So the coefficient of x therefore is 10 plus b. And the constant term therefore is 10 times b. Okay? Now we are given that this is equivalent to x squared plus 3bx plus c. Now if these two expressions are equivalent, that means their coefficients of x squared should be the same, their coefficients of x should be the same, and their constant term should also be the same. Read the question statement again. It says the expressions this and these and this are equivalent. They should be identical. Same coefficient of x squared, same coefficient of x, and same constant term. So what you do is you simplify this factorized form. And that gives you this. And now you compare coefficients. What's the coefficient of x that we have? 10 plus b. What's the coefficient of x that they have? 3b. What's the constant term that we have? 10b. What's the constant term that they have? C. That means 10 plus b should equal 3 times b. 10 plus b should equal 3 times b. And 10b should equal c. Is this all right? We're just comparing the coefficients. If the two expressions are equivalent, they should have the same coefficients of x squared, of x, and the constant term. Now we have two equations. We can solve these two equations. The first one gives us 2b equal to 10. And the value of b turns out to be 5. Put that in the other equation now. 10 into 5, that equals c. So the value of c is 50. And that is what we were looking for. Is that okay? So sometimes we have to compare coefficients like this. Since the two expressions were equivalent, we converted them to a similar form, simplified both of them, and then compared them. Now, this is very important. Let's try to understand this concept first. Let's say you have y equals 3x plus 12. This is an equation. And you have another equation, y equals minus 2x plus 10. How many solutions would they have if you were to solve them simultaneously, at how many points will they intersect these two lines? These are two straight lines, right? At how many points that can they intersect? 1 point. Two lines intersect at 1 point generally. But what's the condition for that? For them to intersect at 1 point, they should have different directions. Their gradient should be different. One has gradient 3 and the other has gradient -2. So they will intersect at some point, right? What if we had y equals 3x plus 12 and y equals 3x plus 10? If we had these two equations, at how many points do these functions intersect? These are both straight lines as well. Normally, straight lines intersect at 1 point. What about these two lines? They they do not intersect, right? They do not intersect. Why? Why do they not? Because they're parallel lines. They have the same gradients. Their y-intercepts are different. If one is like this, the other is going to be like this. They're parallel to each other. They will never meet each other. So it has no solution. You can try solving it and see what you'll get. How do you solve them simultaneously? You can say 3x plus 12, that equals 3x plus 10. What does that give you? 12 equal to 10. That does not make any sense. That's not correct. That means it cannot be solved. Make sense? So linear equations, yes, mostly they have one solution, but sometimes they can have no solutions as well, right? When the gradients are the same like this. What if the two functions were 3x plus 10 and 3x plus 10? So essentially an equation like this, 3x plus 10 equal to 3x plus 10. Does this have any solutions? Sorry? It's the same line. So what does that mean? What do we mean when we say solutions of these two simultaneous equations? We basically think of where exactly these two functions meet each other, right? What about these two functions? At how many points do they meet each other? They're the same line. They have an infinite number of solutions. This equation has infinitely many solutions because it's the same line. एक line ऐसे दूसरी line इसी के ऊपर ये. So they intersect at every single point. There are infinitely many solutions of this equation. How is it different from the previous example? In the previous example, I wrote 3x plus 12 equal to 3x plus 10, right? There were two different functions with the same gradient, and from that we got 12 equal to 10, which was clearly not correct. But what do we get from this? If we take all terms to one side, 3x plus 10 minus 3x minus 10 equal to 0. Eventually you get 0 equal to 0. Is that correct? Yes, that's always correct. 0 always equals 0, right? So no matter what the value of x is, this is always true. This equation has infinitely many solutions. Infinitely many solutions. So straight lines can have no solution if they're two parallel lines, two different parallel lines. They can have one solution if they're non-parallel lines. And they can have infinitely many solutions if you are solving a line with itself simultaneously, right? So it's the same line that we are solving. Basically, 3x plus 10, 3x plus 10, एक ही line को हम आपस में solve कर रहे हैं. It has infinitely many solutions. Does that make sense? What you need to understand from this is, sometimes when you're solving equations, on both sides of the equation, we have something identical. दोनों sides पे same ही चीज है. अब यहाँ पे तो बहुत ही obvious था 3x plus 10 equals 3x plus 10, right? They're visibly equal to each other. But sometimes it's not as apparent. So maybe a slightly different example could be if you have minus 2x plus 12, and on the other side you have minus 2 into x minus 6, right? When you try solving this, eventually what happens is you get 0 equals 0, everything is cancelled. It has infinitely many solutions because you get 0 equal to 0, which is always true. That means you get infinitely many solutions. So when do you get infinitely many solutions? When you have the same function being solved with itself. All right? When you have two identical functions that you're solving with each other. Is that okay? Now, let's take an example. So when do you get infinitely many solutions? When you have a single equation, when you have an equation in which both sides are equivalent, right? On the left hand side and the right hand side, they're equivalent to each other or identical to each other. You get infinitely many solutions. Now, how are you tested on this? Let's take an example. Let's say you have a into x square minus 2b equals 4x square minus 12. It says find the value of b when the equation has infinitely many solutions. What does that mean? Both sides should be identical to each other. If it has infinitely many solutions, that means the left hand side and the right hand side, they should be identical to each other. Can we find the value of b now using that information? What do you have on the left side? On the left side, if you simplify this, you get ax squared minus 2ab. What do you have on the right side? 4x squared minus 12. If these two things are identical, we can compare both sides. We can say a should be 4 and minus 2ab should be minus 12. Right? Only then they will be identical to each other and have infinitely many solutions. So that gives us a equal to 4 or minus 2ab equal to minus 12. Now we already have the value for a. We can input that in the other equation. That gives us minus 2 into 4 times b equals minus 12. And that gives us the value of b, which is 12 over 8. And that's 1.5. That's the value of b that we're getting. Is that okay? So whenever an equation has infinitely many solutions, what that means is both sides are identical. So you can just compare them. Now, the same problem is sometimes worded slightly differently. So look at the next example now. It says, given that kx plus 3 into 5 minus 2x equals 15, find the value of k if the equation is true for all values of x. What does that mean? True for all value of x. That means no matter what value of x you input there, both sides are always identical. Right? If it's true for all values of x, that means how many solutions do we have? Infinitely many solutions. All values of x, that means any value of x can be input there. That's infinitely many possible values. So use the same idea as before. You say both sides are supposed to be identical. Simplify both sides and compare them again. Right? K x plus 15 minus 6x, that equals 15. Now, let's bring the like terms together. What's the coefficient of x? K minus 6 whole multiplied by x plus 15 equals 15. Is that okay? What's the value of k now? How do you find the value of k now? Making x the subject, or k is the subject? We have two unknowns, remember? We can't find the value of k like that. We have to compare both sides. What are the constants on both sides? 15, 15. What's the coefficient of x on the left side? K minus 6. What's the coefficient of x on the right side? 1. If it was 1, we would have 1x plus 15. That means x plus 15. We don't have any x here. What's the coefficient of x on the right side? If there's no x, that means it has to be 0. So on the right side, you can think of it like this. It's 0x plus 15. And now you compare the two sides, and that gives you k minus 6 equal to 0 and k equals 6. Is that okay? So infinitely many solutions or true for all values of the variable, both of these things mean the equation has equivalent expressions on both sides. The left hand side and the right hand side, they're identical to each other, and you can compare them like this. No problems? Okay. Now, this was the other type of problem that we discussed earlier. For straight lines in particular, when you had y equals 3x plus 12 and y equals 3x plus 10. How many solutions did these two equations have? Zero solutions. They did not intersect at all because they were parallel to each other. The general rule about it is you get no solutions whenever everything else in an equation is the same except the constant terms. Does that make sense? When you have an equation in which everything is the same on both sides except the constants, because constants here represent the y-intercept, right? So they basically move the equation or the function up or down. If everything else is the same and only the constant is different, that means they will be parallel to each other and never intersect, and therefore have no solutions. Okay? So an equation has no solutions when both sides are equivalent except for the constants. Let's take an example. Let's say you have 3cx minus 4 into x plus 1 equals 2 into x minus 1. Find the value of c when the equation has no solution. Take a minute, everyone. Try this and see what you get. What's the value of c when the equation has no solution? No solution का क्या मतलब है? Everything is identical except the constants. How do you think about this? Anyone? How do we think about this? In order to have no solutions, everything should be the same except constants. So we do something similar to what we have been doing before. Simplify both sides first. This gives you 3x minus 4x minus 4 equal to 2x minus 2. Okay? Now, what are the constants on both sides? Minus 4, minus 2. They are different. But apart from the constant, everything else should be the same. That means the coefficients of x, they have to be the same. What's the coefficient of x on the left side? Take x common. That leaves you with 3c minus 4 inside. On the right side, you have 2x minus 2. Compare the coefficients. On the left side, you have 3c minus 4 as the coefficient of x. On the right side, you have 2 as the coefficient of x. Compare them, and that gives you 3c minus 4 equal to 2, and c equals 6 over 3, which is 2. The value of c turns out to be 2. Is this all right? How many of you understand this? Can I raise a hand? Roma, you're not paying attention. कि आपने रजिस्टर कर लिया है तो इसका कुछ फ़ायदा उठा लेना. आप क्लास में भी आ गए हैं. क्लास में आके जो है फोकस नहीं होगा तो फिर टाइम वेस्ट होगा ना. What about example 5 now? How many solutions does the equation 6 into x plus 2 equals 6x plus 8 have? What do you think? This equation, how many solutions does it have? No solutions, right? 6x and 6x, they get cancelled and you get 12 equal to 8. That does not make sense. This is never true. So there are no solutions. You can say zero solutions. Okay? Okay? Now, this is another type of function that you need to know about. How many of you are familiar with this function? Absolute value function. Okay. So we have a function that's called absolute value function. It's also known as modulus function. And it works like this. It has a simple function. What it does is anything that you input inside it, it makes it positive. So this is the sign that we use for this, these two vertical lines. And this is read as modulus or absolute value of -3. All this function does is it makes whatever is input inside it, it makes it positive. So -3 modulus, what should that be? 3. If you have -5 modulus, what should that be? 5. If you have 8 modulus, what should that be? 8. It's not that the sign is changing. Basically, the output has to be positive. If it's already positive, it remains positive. If it's negative, it's converted to something positive. That's what a modulus function does. All right? Now, you will have to solve equations involving the modulus function. For example, let's say you have this equation, modulus of x equals 4. What's the solution, or what are the solutions of this equation? X equals 4 or -4, because when you input 4 inside it, the equation satisfies. When you input -4 inside, the equation satisfies. Make sense? If you have x minus 3 modulus equal to 5, what are the solutions to this equation? X minus 3 modulus equals 5. 8 and -2. So how did you actually think about it? You basically thought of it like this. In order to get 5 at the end, the expression inside the modulus, it should either be equal to 5 or it should be equal to -5, right? That gives us x minus 3 equal to 5 or x minus 3 equal to -5, and one of them gives us x equal to 8 and the other gives us x equal to -2. Is that okay? Make sense? Now that's how the modulus function works. Now, once you understand that, how are you going to solve equations involving this function now, modulus function or the absolute value function? All you have to do is, whenever you have this modulus sign, what you're going to do is you're going to remove the modulus sign, and instead of that, put plus minus. Make sense? Remove the modulus sign and put plus minus instead of that. Now you can put that plus minus on either side. It could be on the left side or on the right side. It's the same thing. You can also do x plus 3 equal to plus minus 8. That will give you the same result as well. Okay? So the idea is you remove the modulus sign and put plus minus. So you get two cases, one with plus sign, one with minus sign. And then you just solve those two equations one by one. Let's solve this one. So we remove the modulus sign, we put plus minus. Instead of that, what does that give us? X plus 3 with the plus sign equal to 8, or minus into x plus 3 equal to 8. The first one gives us x equals 5, and the second one gives us minus x minus 3 equal to 8, and the value of x will turn out to be minus 11 from this. These are the two solutions of this equation, x equals 5 and x equals negative 11. Any problems? So whenever you have a modulus or absolute value function, this is the standard process for solving equations like these. Remove modulus, put plus minus, break your equation into two parts, one with the plus sign, one with the minus sign. Solve those two equations individually, and you should get the result from that. ठीक है? Number of solutions to equations. We talked about this briefly before as well. We talked about having no solutions, one solution, or infinitely many solutions, right? But sometimes you have some other type of function and they ask you for the number of solutions. How do you figure that out? If you have this equation, for instance, how many solutions does this equation have? Sorry? 2. So you're saying 2 because it's a quadratic equation and quadratic equations have two solutions. But do quadratic equations always have two solutions? Do quadratic equations always have two solutions? Does this equation have two solutions? Yes? Anyone? How many solutions does this equation have? 2x minus 3 whole squared equals negative 1. 1? What's that one solution? Two solutions? What are the two solutions? There's one solution. What's that? What's that solution? So you're not just going to look at the equation and say it's a quadratic, so it has two solutions, or it's a modulus function, it has two solutions, like it did in the previous example. You'll have to check that. Think of it logically. You have 2x minus 3 whole squared. You're squaring something. And on the right side, you have negative 1. Is that even possible? Can a square ever be negative? So there's no value of x that you can input here that gives you negative 1. So it's not possible. We'll be talking about quadratic equations in a bit more detail later on, where we talk about b square minus 4ac and its relation with the number of solutions an equation has. वो हम देखेंगे in one of our later classes. But this is pretty obvious just by looking at it. It should not require any working. On the left side, you have a square. A square always has to be greater than or equal to 0. The least value it can have is 0, right? It can never be equal to negative 1. So this is not possible. So how many solutions does this have then? No solutions. It has 0 solutions. right? If you wanted to solve it on a calculator, what would you do for that? You would have to simplify this first. You would simplify it to 4x squared minus 12x plus 9, and then minus 1 from the other side as well. You can bring that to the left. It becomes 4x squared minus 12x plus 10 equal to 0. Now put this on your calculator and the quadratic solving function, and you should get no solutions. Your calculator is going to give you something, and then I with that. That's complex solutions. So you can basically think of it like this: that there's no solutions. Okay, it's not part of the syllabus for SAT, the iota thing, but your calculator gives you something in terms of I. All right, that's not real. Okay, that's not an actual number. Another way to think about this could be, if you don't want to do this simplification even, you could use Desmos for this as well. How do you use Desmos for this? You treat this as two separate functions. There's this function, y equals this, and there's this function, y equals minus 1. Remember graphs of functions, O levels, how you used to solve equations graphically? You used to break them down into two parts. So you have y equals this, or you have y equals this, right? And then on the graph, you see at how many points they intersect. That's also something that you can do, in which you don't have to think much. All you have to do is go to Desmos. You'll have this available. Just write down those two functions. Y equals 2x minus 3 whole squared, 2x minus 3 whole squared. That's one function. And the line is y equals minus 1. You see, they're not intersecting, right? So that means there are no solutions. So you can look at it graphically as well. Just input those functions in Desmos and see if they have any points of intersection or not. Make sense? What about this now? How many solutions does this equation have? X minus 10 modulus equals 0. How do you solve modulus equations? We just discussed that. Remove the modulus sign. Put plus minus. Plus minus x minus 10, that equals 0. That gives you either x minus 10 equals 0 with a plus sign, or minus into x minus 10 equals 0. The first one gives you x equals 10. The second one also gives you x equal to 10. How many solutions do you have then? That's one solution, right? Because they're both the same. You can do this on your on Desmos as well. This is also possible. You'll say this is one function, y equals this. This is the other function, y equal to 0. All right, and plot these two functions in Desmos now. How do you do that? Modulus of x minus 10 on Desmos. Yeah. So right at the bottom there, you see this button. Can you see that? Bottom left, right? A, and then you have two vertical lines around that. So you say modulus of, what was the function? X minus 10, x minus 10, and then modulus closed. This is the graph of the modulus function. It's a V-shaped graph like this. What was the other function on the other side? Y equal to 0. It's only touching at one point, right? So it has one solution. So equations can be solved, or you can find the number of solutions like this as well. If you have one variable and you want to solve those two equations, you can do it like this.